For today's video, we will answer a math challenge given by one of our followers. And the question goes like this. Given that A, B, C are distinct such that A cubed plus 2A squared plus 3A plus 4 equals 0, B cubed plus 2B squared plus 3B plus 4 equals 0, C cubed plus 2C squared plus 3C plus 4 equals 0, then our goal in this question is to find the value of this expression 1 plus 2 over A minus 1 multiplied by 1 plus 2 over B minus 1 multiplied by 1 plus 2 over C minus 1. Now you can pause this video if you want to give this problem a try. Now suppose you pause this video. Now let's see if you got the correct answer. So in this question, given these three equations and A, B, and C are all distinct, then our goal is to find the numerical value of 1 plus 2 over A minus 1 plus multiply by 1 plus 2 over B minus 1 multiply by 1 plus 2 over C minus 1. Now, seeing these three equations, the initial information that we get is A, B, and C are the roots of a given equation. And the question is, what is that equation? So what we're going to do is to replace A, B, C with the variable x. So this is the cubic equation with the roots of A, B, and C, because if we replace all x with A, this is equal to 0. If we replace all x with B, this is also equal to 0. And that's also true if we replace all x with C. So, given this information, we can now answer this question. Alright, so let's set aside this result. Now, don't forget that our goal in this question is to evaluate this expression. So, let's get this expression. So, we have 1 plus 2 over A minus 1, 1 plus 2 over B minus 1, and so on and so forth. Now, what we're going to do is to simplify this expression a little bit. So, take note, when we add 1 and 2 over A minus 1, we have A minus 1 plus 2 on the numerator, all over A minus 1 on the denominator. Now, negative 1 plus 2, this is just positive 1. So, the numerator is A plus 1, the denominator is A minus 1. We will do the same thing on the second term. If we add 1 and 2 over B minus 1, we have B minus 1 plus 2 on the numerator and B minus 1 on the denominator. And negative 1 plus 2, this is just positive 1. And we will do the same thing on the third expression. So we have here C plus 1 over C minus 1. And if we multiply all of this term, we have A plus 1 multiplied by B plus 1 multiplied by C plus 1 all over A minus 1 multiplied by B minus 1 multiplied by C minus 1. And this is now the expression that we want to find. And this is the same thing as the previous one. Alright, now to find this value, we will use two methods. And the first one is the Vieta's relation. Now in this cubic equation, having the roots of A, B, and C, we can say that the sum of the roots, A plus B plus C, must be equal to negative 2. And the pairwise product, AB plus BC plus AC, must be equal to this 3. And the product of these roots, ABC, must be equal to negative 4. So using the Vieta's relation. Now let's get the expression that we want to find. Now what we're going to do is to simplify this. Let's multiply A plus 1 and B plus 1. If we do that, we get AB plus A plus B plus 1. So let's replace this. Next, if we multiply AB plus A plus B plus 1 multiplied by C plus 1, we get something like ABC plus A plus B plus C plus AB plus BC plus AC plus 1. So notice, we have here the product of the roots, the sum of the roots, and we have the pairwise product. So now, let's replace this numerator. Now, if we do the same thing on the denominator, we get this product. Alright, and let's replace this. Now, at this point, notice this negative AB minus BC minus AC if we factor out negative 1, we have negative of AB plus BC plus AC. Now at this point, notice that we have a value for the product of the roots ABC. This is just negative 4. So we can replace ABC with 4. Negative 4 rather. And the sum of the roots A plus B plus C, we know this using the Vieta's relation. This is just negative 2. So this is just negative 2. And the pairwise product, AB plus BC plus AC, this is just positive 3. So we can replace this with positive 3 like this. And if we simplify the numerator, negative 4 plus negative 2 is negative 6, plus 4, this is just negative 2. And the denominator, negative 4 minus 2 minus 3 minus 1, this is just negative 10. And negative 2 over negative 10 is, technically speaking, this is just 1 over 5. Therefore, this expression right over here must be equal to 1 over 5. And also 1 over 5 is the same thing as this expression right over here. Now, here's the first method, the Vieta's relation. Now, how about the second one? The second method is the zero of the equation. Now, notice we have an equation, x cubed plus 2x squared plus 3x plus 4 equals to 0. And we know the roots of this cubic equation must be equal to a, b, and c. So we can rewrite this cubic equation as follows. We have x minus a multiplied by x minus b multiplied by x minus c. So this is something related to this a plus 1, b plus 1, c plus 1, and so on and so forth. So now, let's set aside this. And what we're going to do to find the value of a plus 1, b plus 1, c plus 1, let's replace all x with negative 1. So this x becomes negative 1. This x becomes negative 1. This x becomes negative 1. And all of this x becomes negative 1. Alright, now let's simplify. Negative 1 raised to the power of 3. This is just negative 1. Negative 1 squared. This is just positive 1. Positive 3 times negative 1. This is just negative 3. And we have here negative 1 plus 2 minus 3 plus 4. This is just positive 2. Now, what we're going to do is, this is not a plus 1, b plus 1, c plus 1. But if we factor out negative 1 from this 3 expression, if we factor out negative 1, this will give us 1 plus a, or a plus 1. This becomes a 1 plus b, or b plus 1. This becomes 1 plus c, or c plus 1. This is just this expression. So, the right-hand side is just negative 1 raised to the power of 3 because we have 3 negative 1s multiplied by a plus 1, b plus 1, and c plus 1. And negative 1 cubed is just negative 1. Now multiply both sides by negative 1. So the value of a plus 1 times b plus 1 times c plus 1 is just negative 2. Alright. So let's set aside this result. Now the goal is to find the value of a minus 1 multiplied by b minus 1 multiplied by c minus 1. So instead of replacing all x with negative 1, let's replace all x with positive 1. So we replace all x with positive 1. Now, simplifying the left-hand side, we have here 1 plus 2 plus 3 plus 4 are simply equal to 10. And again, if we factor out negative 1 on these three terms, this 1 minus a becomes a plus minus 1. This 1 minus b becomes b minus 1. And 1 minus a becomes c minus 1. So the right-hand side is just negative 1 cubed multiplied by a minus 1, b minus 1, c minus 1. And simplifying this, negative 1 cubed is just negative 1. Multiply both sides by negative 1. This is just a minus 1 multiplied by b minus 1 multiplied by c minus 1 is just negative 10. Now, using those values, we can now find the value of this expression. So divide these two equations. And we have here equivalent to negative 2 over 10, which is when we simplify this, we have equal to 1 over 5 as the value that we get a while ago. Therefore, given this condition, A, B, and C are distinct such that these three equations satisfies, then the value of 1 plus 2 over A minus 1 multiplied by 1 plus 2 over B minus 1 multiplied by 1 plus 2 over C minus 1 must be equal to 1 over 5. And as always, we are done.